Hey class, Mr. Moynihan here with another finance video related to finding the target interest rate in order to achieve a certain amount of money in a certain amount of time in a compounding environment. So the problem says, what target annual interest rate is needed for an initial deposit of $4,000 in a tax-free Roth IRA, compounded semi-annually, to grow to $18,000 in 15 years? So a lot of technical language there, but let's look at some of the most important phrases and words and see if we can't figure out what's being asked. Compounded semi-annually tells us a lot of information in a concise way. It tells us that we're going to be using the compound interest formula in some form or other, which is right here. And semi-annually tells us that n is going to equal 2 in this case. Twice a year, you're going to have a compounding. 6 months in and then at the end of the year as well. Just for a bit of background in terms of what this problem is asking, Roth IRAs are individual retirement accounts that have certain tax benefits because you input or contribute money after you've already paid your taxes, and it's sort of an additional revenue source for retirement, of course, when you get to a future age to retire. So it's a good investment, especially for younger people. So certainly relevant to your interests in a couple of years, certainly. So we want to achieve a certain interest rate, right? Our ultimate goal should be some sort of rate, given that our initial deposit, our present value, is going to be $4,000. Make it a bit larger, $4,000. And our future value, or amount, that we are able to extract is going to be looks like $18,000. So a lot of information. Let's see if we can't figure out how to actually do the math to make it work, to figure out what interest rate is needed to achieve this growth. So the future value is $18,000, and the present value is $4,000. We don't know what the rate is, but we know it's going to be compounded semi-annually, so twice a year. So we're essentially doing half the interest for the first 6 months and half the interest for the second 6 months, hence dividing it by 2, raised to the number of compoundings over the entire cycle, which in this case would be n, which is 2, times the length of time, which I forgot to note over here, but the time in question is 15 years. So 2 times 15 power. Our only variable is r, so it looks like we're in luck. We should be able to solve this without too much issue. Let's get rid of the 4,000. It's multiplying all of this parentheses and exponent business. So let's divide both sides by 4,000. And that's the same as 18 divided by 4, right? Just a little computation observation. But 18,000 divided by 4,000 is 4.5. So that's the factor by which we want our money to grow. We want it to become 4.5 times larger. And the question is, what is the rate needed for that to happen? Let's see, 2 times 15 for the exponent will give us 30 years. 30 for the exponent. 30 compoundings. Now it's worth taking a little detour here just to make sure we understand what's being asked right here. 4.5 is going to equal some amount here raised to the 30th power. So some amount that's a bit more than 1 times itself 30 times has to produce 4.5. Well, keep in mind, this is simply a more complicated version of something much simpler. So here, this little flashback. Anytime you have something like, let's say, 9.3 equals x cubed, let's say, you would solve something like that by simply taking the cube root of both sides. The cube root of this side and the cube root of that side, these cancel, giving you just x equals whatever, right? So you get rid of an exponent by using its opposite or associated root. So in this case, to get rid of this 30, in order to get access to this rate of the inside, all we need to do is to take the 30th root of both sides. So by nature, these two operations are opposites, leaving us with just 1 plus r over 2 on the inside. And the other side is going to be probably a weird looking number, but we can find it in the calculator. The 30th root, so I'm going to type in 31st actually, or not 31st, but 30, put in first. And then on a TI-84, all you're going to do is hit math, choice 5 will give you the root. So 30th root of 4.5 will give us 1.0514. 1.0514. I'm going to use the exact value in the calculation, but I'm just writing it down there for convenience's sake. To solve for r, simply subtract 1 from both sides. That gives me the decimal without the 1 equals r over 2. Multiply both sides by 2 to cancel out that division by 2. And that gives us just the rate. And let's see if we can't get caught up in the calculator here. Subtract 1 earlier. Oops, now you can see it. So that was this number right here. Times 2 will give us that amount there. 0.1028. Put that as a percent, as interest typically is. Multiply that by 100, which gives us 10.283%. So if you're able to achieve this level of growth over the course of 15 years in this particular kind of retirement account, then in 15 years your initial $4,000 will become $18,000. So if your risk tolerance is high enough, because to achieve a high interest rate you usually need to have a high risk tolerance to be able to withstand that maybe the risky investments, which might turn out to be really good, the high rate could also fall through and not turn out to be a good investment at all. But if your tolerance is high enough, you can achieve high rates through investment. Hope this helps.